Okay guys, so for our next subtraction equation, I'm going to use the big C method to convert them to improper fractions to subtract. You could do the number line, you could just do the standard algorithm where you convert these by taking one away. So you would subtract like 4 by 7/5. That works too. Do whatever works for you. I'm just doing this method because it's our most recent one. So I would multiply my denominator by my whole number and add my numerator. My denominator stays the same. So 5 times 5 is 25, plus 2 is 27/5. Let's go over here and do this other one. So we're going to do our denominator by our whole number, plus 3, and our denominator stays the same. 5 times 1 is 5, plus 3 is 8. So our new equation is 27/5 minus 8/5. And when you subtract them, you get 19/5. Now you can't leave the improper fraction. You have to convert it back to a mixed number. And I like to count up. So I have 5, 10, 15. If I did one more 5, it would be 20, which would be too much. So 15, 16, 17, 18, 19, and then I add them up. So I have 1, 2, 3, plus 1, 2, 3, 4/5. So our answer, I'll put it up here, is 3 4/5. 3 4/5. All right, for our next equation, we have 1 whole minus 5/8. We can't subtract from 1 whole. We have to convert it into a fraction in order to actually subtract it. So to do that, we need to think of a way to write 1 whole as a fraction. Because we're dealing with eighths, we're going to convert it into 8/8 because 8 divided by 8 equals 1 whole. And now we can subtract. Our denominators are the same, so they're going to stay the same. 8 minus 5 is 3, giving us a difference of 3/8. Okay, guys, our next one says, based on the fractions below, choose the fraction that is not equivalent to the other 3. So we're trying to see which one of these is not equal. So different ways we could do this. We can cross multiply all of them and see if they're equal. We can just simply try to find equivalent of fractions by like multiplying by 2s or 10s or dividing by 2 or dividing by 10. Just using like multiples of the numbers. Completely up to you what strategy you want to use. Thank you, Xander. All right, guys, I decided I'm going to do the cross multiplying because I think it would just be a quick way to see if they're equivalent. So I'm going to start with my first 2 fractions of 3/5 and 60/100. Let's cross multiply and see if they're equal. 3 times 100 is 300. 6 times 5 is 30, and add that extra 0. So we know that 3/5 and 60/100 are equal. Now let's check and see if 6/10 and 6/5 are equal. So 6 times 5 is 30. 10 times 6 is 60. Ooh, they are not equal. But something that I'm looking at real quick is I'm noticing with these 4 fractions, I see 300, 300, 30, and 60. I know if I take 6/10, 30 times 10 is 300, which would be the same as these. So that means if I had 6/10 and I multiplied my numerator and denominator by 10, it would equal this other fraction. So I know it's the same. Where 60, no matter what I multiply by, it's not gonna, I mean, I guess I could do it by 30. No, that wouldn't make sense. 6 times 5 is 30. But then to add 2 zeros would be 3,000. But 5 times 50 doesn't equal any of these either. So 5 times 5 would be 200. Yeah, that wouldn't make sense either. So I know that 6/5 is not like the rest. It's not equal to. So what I decided for this problem, it's the same thing where we're based on the fractions below, choose the fraction that is not equivalent to the other three. So above we did cross multiplying. Down here, I decided I'm gonna multiply and divide to find equivalent fractions to see. So for example, I'm just gonna take these numbers, 6/4, and I'm gonna multiply it by 2 and find the equivalent fraction. And then I decided I'm going to divide by 2 and see what kind of fraction. So I could do the simplified one and I could do a greater one. So 6 times 2 is 12. 4 times 2 is 8. 6 divided by 2 is 3. 4 divided by 2 is 2. Already, I've noticed just by dividing by 2 and multiplying by 2, I quickly saw that we have 1, 2 that are the same. So that shows me that they're equal. Now I just kind of want to double check if I can get anything to equal from 6 and 4 to get to 8 and 4. So if I divided this by 2 and divided this by 2, it would equal 4 halves, not equivalent, right? We could also multiply by 2 and see if it gives us something similar. 16/8. No, definitely not equivalent. I could even cross multiply just to double check and see. 6 and 4 is 24. 8 and 4 is 32. So I would know that 8/4 is not equivalent.